So today we're going to talk about states of matter and atoms. Okay, but first we're going to do a little bit of review from last week. Okay, so we talked about types of matter and we talked about mixtures and compounds. So mixtures are a combination of two or more substances in any proportion. And remember, that is not a chemical reaction, right? So we talked about two different types of mixtures. Remember what those were? We talked about homogeneous mixtures and heterogeneous mixtures, right? So homogeneous, so homo means the same, right? So those are the types of mixtures that look the same throughout when we're done mixing it, right? Heterogeneous mixture, hetero means different, right? And so it's going to look different throughout, like a trail mix, right? It has the peanuts and the M&Ms and the raisins and things, right? Okay, so then what are we talked about homogeneous mixtures. We said solutions and colloids, remember? And then an example of a heterogeneous mixture was a suspension. Remember, those are things that we have to shake up, right? Okay. And then compounds. So we broke that down further into molecules and crystals. Okay. All right. So can you guys give me an example of a homogeneous mixture? So what about like coffee, right? Or tea? If your coffee or tea looks like a heterogeneous mixture, you probably don't want to drink it, right? That would be kind of gross. All right. And then we also learned some gas laws. What are the three gas laws we learned? We talked about Boyle's law, Amaton's law, and Charles' law, right? So let's see if we can match these, okay? So which one increases temperature and results in an increase in pressure, right? That was Amaton's law. And then a decrease in temperature means a decrease in volume. That was Charles' law. That was our balloon experiment, right? And then Boyle's law, that's increased volume, decreased pressure. That was our little marshmallow experiment. Okay. All right. And so here are your vocab words for this week on the class page as usual. And our objectives for today are to understand the role of energy and changes of state, be able to look at a description of a change of state and identify which one it is, compare and contrast protons, neutrons, and electrons, describe the forces that hold the particles of atoms together, given an element symbol from the periodic table, be able to identify the atomic number, atomic mass number, and the number of protons, neutrons, and electrons, and recognize the difference between an atom and an ion. Okay, so if we look at these pictures, okay, let's assume these two pictures are of the same sky, just a few hours apart from each other. Where do the clouds come from? Well, the clouds consist of tiny droplets of liquid water. So where did the water come from? Well, it was there all along, right? In the form of invisible water or water vapor, which then condensed into clouds. Okay. And so condensation is one of our types of changes of state. Now, what do changes of state require? They require energy. Okay. And how do you measure energy? Does anyone know? You measure energy using temperature. So the definition of temperature is the average kinetic energy of the particles of matter. Okay, so what is kinetic energy versus potential energy? Right, kinetic energy is energy of moving things, of movement, right? Okay, so matter either loses or absorbs energy when it changes from one state to another. For example, when matter changes from a liquid to a solid, it loses energy. When it changes from a solid to a liquid, it absorbs energy. Okay, so what are the common changes of states? So you have to have these memorized, okay? So we have melting, freezing, sublimation, deposition, condensation, and vaporization. Okay, so we're going to kind of put vaporization and evaporation kind of together. We're going to differentiate between the two. But okay, so what change of state is this? So we have our liquid water, we fill up our ice cube trays if you still use those, and it turns into ice. So what change of state is this? It is freezing. That's correct. So freezing is changing of state from a liquid to a solid. Okay, so now let's think about the energy. Okay, what kind of energy a solid has? Well, we've talked about this before, right? When we talked about the energy of solids, liquids, and gases, right? So solids have the least amount of energy, right? And we said it's kind of like they vibrate a little bit, so it's kind of like your dog sleeping, okay? And then liquids have a little bit more energy, and then gases have the most energy, right? They're like your dog is really hyper because someone came over and he's so excited to see your friend or whatever, okay? Um, and then how are the particles of a solid packed together? Packed together really tightly, right? So if we remove energy, this will cause the particles in a liquid to start locking together. All right. What about this? Oh, doesn't this look yummy? Okay. What change of state is this? This is melting, right? So it changes from a solid to a liquid. So again, what kind of energy does a solid have? Low. And how are the particles packed together? Really tight, right? So any energy applied is used to overcome the attraction that holds the particles in place. So what will happen to the temperature? It's going to go up, okay? So the temperature goes up, and that's how we melt things, right? What change of state is this? So this is vaporization, all right? So the definition of vaporization is the change of a liquid to a gas through boiling, okay? So what happens to the energy here? It goes up, right? So the particles of liquid gain energy through heat to overcome the forces of gas between them and create a gas, okay? What about here? So here, this is supposed to be a picture of salt water, right? So we mix the salt with the water, we get salt water, right? So what if I mix salt and water and I get salt water, and then I leave it out for several days, like in the winter when it's really dry, okay? What's going to happen to the salt water? Well, the water's going to evaporate, right? And leave the solid at the bottom, the salt at the bottom. So evaporation is a liquid to gas without boiling. Okay, so let's just write those out real quick, okay? So we have, let's see here. We're gonna have our vaporization, right? Which is a liquid to a gas by boiling, okay? Versus evaporation, which is a liquid to a gas without boiling. Okay. All right. And you can get that in your notes. All right. I'm going to erase. Okay. In three, two, one. All right. What change of state is this? Well, liquid can also change to a gas. Oh, sorry. This is condensation, right? This is gas changes to a liquid. Okay. So the gas changes to a liquid. So does this mean the water is seeping through the bottle? No. right? So if you've ever had like an iced tea out on a hot day, right? And it gets this, we call it sweat beads maybe on the glass. That's not because the tea is leaving the cup, right? Or the glass. It's because the gas from the air is condensing onto the glass. Okay. Um, all right. And then here, if have you ever seen a dry ice demonstration? Okay. This is sublimation. Okay, so let's write that one out. This one, that's probably one you're not as familiar with. Sublimation. Okay. So this is when a solid turns directly into a gas. It doesn't turn into a liquid, it turns directly into a gas without being a liquid first. Okay. And then this, so this is supposed to be an example of frost. Okay, this is picture of frost. So this is deposition. So deposition, just be an E there, okay. Where gas changes directly into a solid when gas particles become very cold. Okay. All right, so this is just a helpful little image that is in your book that shows the changes of state. What is wrong with this statement? Water in an open container disappears because it changes into air. Well, water in an open container evaporates or changes from liquid to a gas, right? And we know because of the law of conservation of matter that we cannot create or destroy matter, right? Only God can do that. Um, So this would also be a false statement because of that. It doesn't disappear. I guess we said because it changes into a. Let's see here, but it doesn't disappear. Drops of water on the outside of a cold glass have seeped or sweated through the glass. So what's wrong with this statement? Instead, we want to say the drops of water have condensed from water vapor in the air that came into contact with the cold glass. All right, let's see if we can label this. Okay, so here, calling this a gas, right? And this is a solid, and this is a liquid, right? Okay, so if we're going from a solid to a liquid, what is that? So a solid to a liquid, that's melting, right? What about a liquid to a solid? That's freezing, right? Okay. What about going from a gas to a liquid? Which one is that? So that's condensation, right? I'm just going to abbreviate. And then going from, oh, I put that in the wrong spot. Going from a gas to a liquid is condensation. And then going from a liquid to a gas is what? So that's a vaporization or evaporation. Okay. What about if we go from a solid to a gas? What is that? A solid to a gas. That's like our dry ice, right? So that's sublimation. And then going from a gas to a solid, that's like the formation of frost, right? Which is deposition. Okay, good. Rosemary opened the oven door to check on the cake she was baking. As hot, moist air rushed out of the oven, her eyeglasses steamed. Explain why. Which change of state would that be? Right, it would be condensation. Very good. Okay. All right, so we'll move on to atoms.